Hello dear students, welcome back once again. So now we will discuss about some examples of refraction of light, or we may say some applications or consequences of refraction of light. So just in the previous video, while discussing real and apparent depth, at the very beginning I mentioned that if any object is placed in water or any denser medium, and then if it is observed or viewed from vertically above, that is from air or any rarer medium, then the object appears to be slightly raised up, isn't it? It means its depth appears to be slightly less than that of its real depth, because it is generally shifted in the upward direction. And I also mentioned that if any straight object, that is in straight rod or stick or pen or pencil, if it is immersed some part obliquely, that is slightly, isn't it? Some part inside the water and keeping some part outside water, that is in air, then what will be the result? From our daily experiences, you may have seen somehow, that is the stick appears to be bent, isn't it? And it also appears to be shortened because of refraction of light. But why is it happening? What is its explanation? Let's try to understand it through the diagram. So suppose a stick AB, a straight stick AB, is immersed obliquely, slightly inside the water. Some part is inside the water and the rest part is inside the air. So the water is nothing but the denser medium, and this is the eye. We will try to observe the stick from the rarer medium, from this position. So actually what happens? So you can see the part, this is the tip of the stick. So one ray from the point B will travel through the path, will come out, and it will just move in the direction BE, isn't it? In the direction BE. So then after striking the surface, boundary surface E, then if we draw a normal, then we can easily say that it will move away from the normal. Since here the light ray BE coming from the tip B is suffering refraction from denser to rarer medium, we have already learned. So it will move in the path through the direction EF. Again another ray, you all know that minimum 2 rays are required. Again another ray coming from B, it will travel along path BC. Then again after suffering refraction, after entering the rarer medium, that is air. Okay, that is air. Because I have mentioned A, that's why it will make, so that it cannot make any confusion. So it will move along the path CD. Now, since due to rectilinear propagation of light, human eye never detect the bent path of light. It will always look for its straight path, isn't it? And how is it possible? It is only possible if these two rays are stretched in the backward direction. Isn't it? Produced in the backward direction. Because I will think that I will always try to follow. Because it cannot detect the bent path, it will always follow such that it's linear, it's straight path. So due to that, if you extend the two rays in the backward direction, you will get the point B dash, which will shift the real position of the tip of the stick from B to B dash, and automatically it makes the stick slightly shortened, as well as it appears to be broken also. It seems like that it will appear at the point B, it is broken at the point B. That is, the part AO is straight, whereas it is broken at the point O. Though it is not the reality, it happens apparently. Okay, this is called bending of the stick in water. Okay, so it means, because as you can see that actual depth from B it is raised up, so as well as it appears to be raised up, as well as appears to be shortened, as well as appears to be broken also, isn't it? Due to refraction of light, it raised up. Because of its apparent depth, it appears to be broken. It makes its original position in slightly upward direction. So it means if any straight object is placed in any denser medium like water, and if it is viewed from a rarer medium like air, it appears to be shortened, as well as appears to be broken also. Now let's discuss what would happen if the opposite thing happens. It means if the object is placed in rarer medium, that is in air, and if it is observed or viewed from any denser medium, what would happen? It means suppose any object is placed in air, And if any person sinks into the water, any swimmer or whatsoever, if it observe it from under the water, what would happen? Okay, now you can see, suppose this is an object. At first we will discuss it with this very small piece of object. Suppose a coin is placed at point O, and this is the position of the Y. This is the person, this is the position of the eye of the person, which try to look from the water. So one ray coming from point O, it will just move in the direction OC. It will just incident at this point. Then after diffraction, it will enter into the dead sun medium. So it means in this case, the light ray OC suffers refraction from rarer to dense sun medium, and we all know that in case of suffering from refraction from rarer to dense sun medium, light ray, the refracted ray, due to decrease or slows down of the speed of light, it will move towards it will bend towards the normal. So as it is CE, slightly bent towards the normal. Now again, I cannot detect the bent or crooked part of the light, so it will always search or follow its straight path. So we have to extend the ray EC in the backward direction, which automatically make a straight line EI, and then again we can see it will shift it shifts the original position of the point O from I means image for object. Clear? So the object EC, the straight line EC put in the backward direction, it intersects the AM straight line at the point I, which is the virtual position of the object, which is nothing but the virtual image. Clear? So here you can see opposite thing happens. The real depth was this. If I take any point, isn't it? If I take P, this point. So in that case, the real depth was PO, whereas in this case it is increased PI. It means in this case, instead of becoming shorter, isn't it? Its depth appears to be increased. So in case of any small object like coin or any point like object, small object, it appears to be moved up. It means its depth, instead of become less, it would appear more. But in case of any straight object like straight rod, instead of becoming shortened, it will appear as taller. Isn't it? Very just opposite thing. So from this, these two are very important and very interesting examples of diffraction of light. So from these two examples, we can come to this conclusion that if any object is at first placed in any dead sun medium in water, and if it is viewed or observed from rarer medium vertically above from air, then the object appears, in case of small object, it appears to be raised up. In case of a small object, it appears to be raised up. It means its depth appears to be less than that of its original depth or real depth. But in case of a straight object, it appears to be raised up, as well as it appears to be shortened and broken also. But opposite thing, if the object, a small object like coin, is placed in rarer medium and viewed from dense sun medium, its depth appears to be slightly increased, raised, comparing to its real depth. But in case of a straight object like rod, pen or pencil, if it is kept in the rarer medium, viewed from dense sun medium, that is water, then instead of becoming shortened, it will become straight, isn't it? Then in this case, what would happen, isn't it? Its length will appears to be increased. So these are the two very easy examples. The bending of a stick in water, whereas this appears to be the taller, isn't it? The increase in length of a stick. Now moves on to the second topic, that is advanced sunrise and delayed sunset. I think you have already gone through it in class 8. Okay, so let's try to understand it through diagram. So what do you mean by advanced sunrise? Advanced sunrise means sun actually not risen, but before 5 or 10 minutes we can see the sunrise in advance. It means suppose for an example, at 5 o'clock the sun will rise. 5 AM is the actual time of rising of sun. But at 4:45 we can see the light. Okay, we can sight. Actually it happens again in spite of after setting of the sun. Suppose at 6 PM sun has already set, but still for next 10 or 15 minutes we can still see the fluorescent, isn't it? Fluorescence. Okay, we can feel the presence of sun. Still we can see the light of the sun. How is it possible? This is also due to the refraction of light, but this is called atmospheric diffraction. Okay, so now let's see So now you can see this is the surface of Earth surface, okay, and the dotted line represents the various layers of Earth of atmosphere, that is troposphere, stratosphere, all these are, and each layer have different density. Now we all know that since sun has not risen, so generally in this case the air just above the earth, just above the sun, in this case are slightly warmer than that of the air or atmosphere very close to earth. Since sun has not risen enough, when sun will rise, the land becomes hot. But now sun has not risen, so the atmosphere of the air particles just above the sun, they are slightly warm due to the heat of the sun. So it means they are light. So this is rarer medium. Whereas the atmosphere or air just of the earth are cold, means they are dense. So this is denser medium. So it means when any light ray comes from, okay, will just hit or come from the sun, reach from sun to earth, it will suffer refraction from rarer to denser medium. So it means it will bend, isn't it? It will bend towards the normal. Clear? So any light ray, okay, then due to continuously bending, since the density, since this is denser medium, rarer medium, so it means any layer just at the below, okay, is denser medium, and any layer just below, it means the first medium from the surface of the earth, as we gradually move, the upper layers will behave as rarer medium. It means any layer just below the upper layer will behave as a denser medium, and any layer just above it will act as a rarer medium. Clear? So when sun will move, any light ray coming from the sun, it will suffer refraction from rarer to denser medium, so it will move bend towards the normal. Then due to continuous bending, say this is rarer and this is denser, so it is moving closer, isn't it? If we draw the normal here, isn't it? As you can see, bending towards rarer, denser. Then again, when light suffer from this layer to this layer, again the upper layer will be rarer and the next layer is lower layer is denser. Since the density of the layer of the above, since the temperature of the atmosphere or air above is more and lower is gradually less decrease. So that's why the air just very close to sun are light, isn't it? So they will behave as the rarer medium. As we gradually move towards the earth, the layers, the air is going to be cold and it is more dense. So any layer at the above is rarer medium and gradually move close to the earth is a denser medium. So this layer to this layer refraction from rarer to denser medium, it will move towards the bend towards the normal. Again from this medium to this layer to this layer, again from rarer to denser medium, continuously bending, again further bend of light towards the. In this way, due to this continuous bending, means successive refraction from rarer to denser medium. As I mentioned, above layer is rarer medium, any layer just below the above is a denser medium. So light will continuously bend towards the normal. So due to this successive bending of light, it will reach at the earth. You can see further bending. Again you can see there is a huge bending of light. Again human eye cannot detect the bending path of light, so it will follow the straight path, and to do that we need to extend it in the backward direction, and you can see which generally makes the position of the sun just below much above than its real position, isn't it? So I will think the sun is coming, the ray is coming from this, which is the virtual image, we can say virtual position, virtual image of sun. So actually sun is here before sun setting. So sun will rise at 5, and this is maybe, for example, this is the scenario at 4:45 am. Clear? For an example, I am taking the time. Actually, I don't actual time. Okay. So this is the real position of the sun at any particular moment before the sun rising, before the rising of the sun, just below the horizon line, isn't it? This is the horizon. This is the horizon. The horizon is the line where the earth's surface and the sky meets with each other. So this is the horizon line. So before the rising of the sun is obviously below horizon. So I will think the ray is coming from this, and I will determine Okay, I will make this is the virtual position of the sun because of the rectilinear propagation of light. Actual position of sun, real position of sun, because the sun is not risen. Okay, because sun is not risen, it will just rise after 15 minutes. So it is below the horizon. But because of this refraction, this refraction, the magic, this is nothing but the pure magic of refraction. So due to refraction, it makes the sun to take its virtual position from S to S dash. That's why it's called advanced sunrise, because sun will rise at 5 am, but I is saying that I will appear, human I will appear. Okay, I will think that as if it is coming from S dash. So after 15 minutes sun will rise, but in advance it is saying S dash. That is, it is as if it is that the sun is okay, take its position at this position, that is above the horizon line, which is nothing but the advance, because sun is not risen. Okay, it's not risen, but it is already saying just 15 minutes ago. Okay, 15 minutes before. Same thing happens after sunset. After sunset, suppose at 6 p.m. sun is already set. So we should not was okay, so sun should not be visible just after 6, but still for next 15 minutes it is still visible, the light. It is the same. Again, continuously bending, isn't it? So the layer, okay. So layer, this, isn't it? What happens? So throughout the day, throughout the entire day, okay, the sun, isn't it, gives light to the land. So the atmosphere or the air just over there becomes hot, isn't it? You can see. So whatsoever. So in this case again, light suffers diffraction from rare to. Now so in this case same thing happens. Same thing happens. Okay, again through continuous bending, light becomes okay. Continuous again sun is here. Okay, through the entire day by giving light it was hot. As soon as it is just strike the evening, it becomes cold, isn't it? By radiating heat, the atmosphere or the earth surface just rejecting the heat and it becomes cold. Whereas the atmosphere or air just above it also becomes cold, it also behave as a denser. Because sun is here now. So since sun is here, by absorbing the heat from the sun, the atmosphere or air just above this layer just close to the sun, it will become, isn't it? It will become heat or hot. So it will become light, it will behave as a rare and medium. So same thing happens. What was happening just before the sunrise, it will exactly happens in case of sunset also. Again, due to continuous bending, the upper layer will behave as the rare and medium, and just layer just below it will behave as dense and medium. So light will suffer diffraction from rare to dense and medium. It will continuously bend towards the normal, and further bending it will reach to the earth, to the human, the eye of to our eye. Then again, same thing happens. It cannot detect the bent path of the light, so it will follow a straight path and it will think as if it is coming from this. So by sketching the light rays in the backward direction, it made its virtual position S, that is S dash. In spite of after setting the sun, that is after seeing the sun just below the horizon, still it will visible. Then after some time it will be totally dark, then there will be no light. So when light cannot come, so there will be no light, so there will be no refraction. So this is delayed. This is delayed. Advancement, sun is not risen, it's not risen enough, but raise its position, next is virtual sunrise or advanced sunrise. After setting of the sun, still we can see both the cases. In spite of not having sunrise, sunlight can be seen, sunlight can be visible. And again after sunrise, so setting of sun, that is below. So in the two positions, before sunrise and after sunset, sun is just below the horizon line. In spite of sinking of the sun below the horizontal line, before sunrise and after sunset, sun is still visible. This is due to pure refraction of light. Hope you have understood.